We're just waiting on the last few people to log in. We'll start in about 2 minutes. We're just waiting for the last few people to log in. We'll start very shortly in the next minute or so. Okay, I think we have everybody in attendance at this point. Hello and welcome everybody. Thank you for joining our webinar today. The focus of this session is UDFBs, our user-defined function blocks, which are an enhanced feature as part of our Cscape 9.9 Service Pack 3. Please use the questions or chat function in your control panel to ask any questions throughout the session. So whenever you feel like asking a question, by all means, please do, and we will endeavour to answer all of them at the questions and answer session at the end of the presentation. We'll also make a recording of this presentation available to you on the website in the next 24 to 48 hours. Okay, so with that, we'll start the presentation. Thank you.
Hi, today we'll be doing an introduction of user-defined function blocks for our tag-based advanced ladder logic. Okay, so let's take a quick look at our agenda for today's tutorial. We'll start by looking at what user-defined function blocks are. There will be lots of demonstration time today. We'll show you how to use, create, debug, and nest UDFBs. We will cover the capabilities within Cscape for UDFBs, and we will finish by doing a live questions and answer session. Let's start by answering the question, what are user-defined function blocks? As the name implies, these are function blocks that are created by users. It is a very efficient way of creating reusable code and is supported in both IEC 61131 logic and tag-based advanced ladder logic. UDFBs are comprised of standard instructions, and one of their key features is that they are instantiated, meaning they allow for multiple instances of themselves that can be scattered across your code to be ran all at once. So, how does a UDFB compare to a subroutine? Subroutines are called using the call instruction. It can be called from anywhere in the program, but it's always calling the same section of code with the same variables. UDFBs, however, can be placed directly in the main logic block. Subroutines can have a single instance, where UDFB can have multiple. And finally, subroutines have a single set of variables, where UDFB can have a set of variables for each of its unique instances, which is probably the biggest difference between it and a subroutine. So now I'm going to go through the process of using a UDFB. First, you have to create your UDFB. Next, you have to place an instance of that function block in your logic somewhere, and debug it to ensure you don't replicate buggy logic. Once the logic is well proven, through debugging, you can proliferate that code for additional instances in the same project, or maybe even in your next project, by saving it and recalling it later. The process of creating a UDFB is made up of 5 steps: naming it, assigning input variables, assigning output variables, assigning private variables, and creating a logic. During the creation of your logic, if you find you need to assign additional variables, you can do so, as this is an iterative process. So now we're going to go through a simple example of a user-defined function block, which calculates the volume of liquid in a vertically oriented cylindrical tank. For this example, our input variables are tank diameter and fill height of the liquid in linear units. We don't have any private variables, but our output variable is going to be volume of liquid in cubic units. To accomplish this, our function block needs to consider the formula that volume is pi times radius squared by the height of the liquid. So now we're going to Cscape to take a look at how we're going to define this particular liquid volume user-defined function block. Before you start, make sure that you have tag-based advanced ladder logic selected when creating a program. To begin, go to the top left of your screen to UDFB modules, right-click and select New Enhanced Logic Block and give it the name liq_vol, short for liquid volume, which is how I'm going to reference it for the rest of this tutorial. Alright, so now with our UDFB created, we can see this screen, which looks very similar to a subroutine, but remember, they're not the same. So as you can see, when I created my new UDFB liq volume, a new window was created for it in my project variable window, under retained variables. We start by assigning our variables to liquid volume, and do this by right-clicking, scrolling up, and selecting Add Variable. For UDFBs, we're prompted between selecting an input parameter, output parameter, or private variable. So now, let's enter our input and output variables. First, we'll enter our input parameter diameter as type real. Next, our input parameter fill level as type real. And lastly, our output parameter volume as type real. Okay, so now we're ready to code. So let's begin by placing down a normally open contact here. So now let's place down an always on tag onto our contact. What I would usually do is place an always on variable that's tagged to S7. But in this case, we already have an array that's been created called S that's tagged to all the system bits. Therefore, S sub 6 is equivalent to always on because arrays are always 0 based, making S sub 6 equivalent to %S7. So I'm going to go ahead and add S6 here. Next, we're going to add a math expression. So to do this, go to the left of our screen to Math Operations, grab an expression, and place it here along my top row. Okay, so let's begin to write our equation. So to reiterate, the volume of water is calculated by multiplying the radius squared by pi by the height of the fill level. We're working with real variables, so I'm going to adjust the settings as such by clicking here, scrolling down, and selecting real. To start, we first have to place down our volume variable, and to do this we can't just write volume, but we have to call liq_volume to gain access to it. So we write liq_vol dot volume equals. So now we want to get the radius, but we don't have it, but we do have the diameter. So open bracket liq_vol dot diameter, and we're going to divide that by 2 to find the radius, and close bracket. So before I square it, I'm going to add in pi at the beginning. So 3.14159, and multiply that by the radius. To square my radius, I'm just going to multiply it by itself. So open bracket liq_vol dot diameter divided by 2 and close bracket again. Okay, so now the last variable to add is fill level. So I'm going to add that to the end. So multiplied by liq_vol dot fill level. Okay, so now everything seems fine. I'm going to click OK. Alright, so it's popped up and everything seems fine. Okay, so we've created a basic UDFB which takes the diameter and fill level of a tank and gives back its volume. So for example, if the inputs are in inches, the output would be in cubic inches. If it's in meters, then the output would be in cubic meters. So once we've created the logic of our UDFB, the next step is creating a unique instance of that function block and to place it somewhere in our logic. Before we start using our newly defined function, let's assume that in this application, the reason we created our UDFB was to quickly calculate the volume of water in multiple tanks. So to make this example more realistic, we're going to create an array of tanks, and to make it even better, we're going to utilize the structure feature so that we can have a series of variables in a structure format all tied to an array of tanks. So I'm going to start by creating a structure, and to do this I go to retained variables, right click, scroll up and select Add Structure. So now that it's created, we're going to rename it. So right click, scroll up and select Rename Structure, and we're going to call it Tank. So now we're going to add some variables to our structure. So we'll add diameter, fill level, and volume. These variables are not required to have the same names as in the UDFB, but I'm naming them as such for clarity. So now we just add our last variables, fill level and volume. I also have to make sure that they're all type real. So let's do that. Just to demonstrate that all of the variables within Tank don't have to be used, I'm going to create a new variable, height, which displays the height of the tank itself with type real. So now we're going to create a variable that utilizes the structure tank. So go to Retain Variables, right click, scroll up and select Add Variable, which I'm going to rename to Water Tank. Then for the type, I double click, scroll down the list and select Tank. So now, in this example, we're going to say that I have 16 water tanks. And to show this, I'm going to dimension water tank to 16. So now I have water tank 0 to water tank 15, which all follow the structure with diameter, fill level, volume, and height. Now we're going to utilize our UDFB to calculate the volume for some of these water tanks. So I'm in my main area for my logic, and I have an always on tag F6 down on the top row. If you look under the project toolbox, I have a category called UDFB, and if I expand that, I can see my liquid volume UDFB that I created. So now I'm going to select that UDFB and place it down on my top row. One of the unique powers of UDFBs is the ability to have multiple instances of the same UDFB. So we have to name this instance, and we're going to call it water_tank1. So now that we've created our new unique instance of water tank 1, we see that we have a pop-up that has all of our predefined input and output specifications. To start, we have to select our diameter, and we do this by clicking our arrow here to pull up a list of our variables. We now see our water tank array, and if we click it, it displays each item in the array. So now we're going to select the diameter in water tank sub-0. We can now repeat this process to get the other variables from water tank sub-0. We're doing the same for fill level and volume. Now that we've created the calculation for the volume of our water tank in water tank sub-0, we can repeat the process for the rest of the water tanks. So I'm going to drop down a normally open contact, name it S6 for always on, and next I'm going to drop my liquid volume UDFB, and we have to give it a new instance name, which we're going to do and call it water tank 2. So now I'm going to fill in my parameters. So for diameter, water tank sub-1 diameter, and fill level, water tank sub-1 fill level, and volume, water tank sub-1 volume. So that's how you utilize multiple instances of this simple UDFB, although you could use this same procedure for something much more complex. We've now created our function block and applied multiple instances of it, but before we use it in too many places, we first have to debug it. When we debug, we only want a single instance to be enabled, as this makes troubleshooting much easier. Okay, so now let's take a look at our debug process. To reiterate, it's very important when debugging that you only have one instance of the UDFB you want to debug running. So I'm going to change this normally open contact in my second instance to a normally closed contact, so that only my first UDFB is running. Okay, so to debug, I'm going to move from my main module to my UDFB module. I could enter debugging mode, but for the math expression block, it doesn't show any live data. So for more effective debugging, we're going to be utilizing the data watch feature, which is this icon at the top of the screen. So here you can see I've added my tank diameter and fill level, and that my UDFB is calculating the volume. So just double checking this calculation, it does look good. So now we're going to change the fill level and see if our volume changes. So we double click on fill level, and we're going to change 2.5 to 2. And as you can see, our volume has changed accordingly. Okay, So now we've successfully debugged our UDFB with only one instance of it running. So now we can go back to our main loop and with confidence add as many instances of this UDFB that we need. Now we're going to talk about some of the other capabilities with UDFBs within Cscape. You can effectively cascade UDFBs, meaning you can have the output of one function block as the input to another function block. To do this, you must follow the rule of having only one UDFB per rung, as you can see in the images on screen at the moment. You can protect your function blocks with OEM protection. So how does this work? Well, lots of OEMs or system integrators want to give their users the ability to use Cscape, but don't want to actually give away their intellectual property. So OEM protection allows users to use logic in their programs without being able to see the contents of that logic. This approach within UDFBs allows you to provide function blocks to your users where they can add their own inputs and outputs but can't see the logic behind it. To get this feature, you must first enable security, turn on OEM ladder support, and for that particular UDFB that you want to protect, right-click and select OEM Protect. You can import and export user-defined function blocks. This can be very useful if you want to build up a library of UDFBs that you can use from project to project. To export a UDFB, you right-click on it in your Project Navigator section, select Export and name your file. And if you wanted to import that same UDFB in another project, right-click on the logic modules in your Project Navigator window, select Import and retrieve the file name from earlier. There are a couple of features that we don't have yet, but we are working on. For example, a formal UDFB library function and the ability to add a graphics element to our UDFBs. You can now nest your UDFBs. So what does this mean? It means you can create a UDFB which embedded in its own logic contains another UDFB. So now we're going to go through a nested UDFB in Cscape. So we're taking a quick look at two UDFBs. The one on screen at the moment is called volume to gallons, which is two inputs and two outputs. One input is the cubic volume that was previously calculated, which can either be in cubic meters or cubic feet. The other input shows whether the volume coming in is metric or imperial. So if the Boolean value is 1, the volume is in cubic meters, and if it's 0, the volume is in cubic feet. Next, it's going to calculate two outputs, volume in number of gallons and number of liters. So if the input is imperial, it's going to convert from cubic feet to gallons and liters. And if the input is metric, then it's going to convert from cubic meters to gallons and liters. Okay, so now we're going to take a look at the other UDFB we created, called cylinder volume. This function takes the linear dimensions of the tank along with the fill level of the liquid, and it calculates the volume of liquid in either cubic meters or cubic feet. It would also be useful to find the volume in gallons and liters, and to do this, we've embedded our previous UDFB inside it. This is displaying our nested capability, and to be sure that it works, we have to be certain that our inputs and outputs from this embedded function are passed through. To do this, we're going to take a look at the details of our embedded function cylinder volume and verify that the metric flag and volume total is passed through, and that there's a path for gallons and liters to pass outward. So, if we take a look at our cylinder volume function, we can see that our metric flag and volume total have been passed through, and that there's a path for gallons and liters to pass out. So that's how you nest one UDFB inside another.
Okay, that was short and to the point, hopefully. We have a few questions in, which we shall get to. Let me see now. Is there an available UDFB library in Cscape? As outlined in the last couple of slides there, no, not yet. But it's a reasonably easy function to use the export and import options to maintain a library yourself. It's something we're looking into, and I'm sure it would be of use to everybody if we created some simple UDFBs and set them in a folder in Cscape, but we are looking into it. We're also looking into adding graphics objects into UDFBs. to make that things like PID and indicators and push buttons, etc., to make all of that a lot easier. What's next? Can a UDFB created in advanced ladders with tags be used in an IEC program and vice versa? No, at the moment, no. A UDFB created in advanced ladder with tags is exported as a .cpu file. The format of the IEC editor exports it as a different type, .Cscape 5 file type. So no, they're not interchangeable. Is there a limit to the number of UDFBs allowed in a single program? The maximum limit is controlled by the controller logic memory. So you can check that with the error checker as you're going along. What's next? What is the maximum number of nested UFBs? The maximum number is 8. Anything more than 8 will cause an error. Now, nesting 8 UDFBs in one UDFB may be a bit complex, but anyway, the maximum is 8. What's next? Can you share the example program created during the presentation? Absolutely. A recording of this session will be up on the website tomorrow or Thursday, and we'll ensure that an example file with the tank levels is included with that. Anything else? Subroutines are UDFBs. I don't understand that question. Is there any more detail on that? Okay, so yeah, okay, the difference between subroutines and UDFBs. Again, it was alluded to within the presentation there. A subroutine is one set of variables. A subroutine is created and called from anywhere within the logic, but it is one set of variables. A UDFB is a function block. Consider it, once it's created, it can be used anywhere within your logic. Think of it as similar to, you know, a move block or a comparator or anything like that. It's instantiated, which means that it's each instance of it, each variable is different in each UDFB. So that's the main difference. Can we use all variable types as inputs to UDFB, comms, etc.? Yes, is the short answer. All variables can be used. Now, you would need to be careful using things like comms, because if you have multiple comms ports open at the same time simultaneously, it may cause you some issues. What else have we? Let me see. Can structures be used outside of UDFBs? Yes, structures are totally independent from UDFBs. We just use them in the example to make it easier. Anything else? Is there a limit? Yeah, we've answered that one. I think that's it. Any other questions there? No. That's it. Okay, everyone. Thank you for your time today. We hope you'll join us for our next session. You'll get details via email in the next day or so. Again, thank you.